Okay, Ahmed, can you just quickly before we start for real, can you just test sharing your screen? Maybe at the bottom.
Yes. You can see my screen and you
Yes,
can
I
hear me.
can. You have a
Okay.
nice little inception of Bevy. All right, perfect. You can stop sharing, and then we'll get things almost going. It's almost like we timed this for it to work properly. So, all right, let me share my screen. We're at 58. It's gonna let people still come in. We're at 19. So I'll go on the 11:59. I'll share my screen so that way we already have something to start. All right, it's noon sharp. So hi everyone. So my name is Stacy Verno. Thanks for joining us on this GDG Cloud Montreal Q2 event, live from well my office at home, and I think Ahmed is live from Google Toronto. So yes, our event will be around like infrastructure as code on GCP and specifically with Terraform. So we'll go with a little classic Terraform with also some new interesting things coming on GCP. So that's going to be an agenda for today. A little intro, a little TLDR on how to ask questions, a little kind of like 101 like Terraform on GCP. Super simple. This is not a deep dive. There's some great material out there from Google and HashiCorp itself when it comes to Terraform. So we just want to like show you cool stuff. Then we'll have a trifecta of demos. So we'll do reverse Terraform, which is also known as uh, inception of this was called something called, or still called Terraformer from the Waze SRE team. Demo number two will be about like policy guardrails for Terraform. So basically, when you do a Terraform run, like a plan, be able to make sure that it doesn't violate any policies that are in place. Something that was also part of the, like, let's say, like the Forseti toolkit with the Terraform config validator. That's now also part of a baked in into GCP as a G Cloud command. And then we'll have Ahmed, who's actually going to do his super cool demo, and then we'll wrap things up. So just mention your speakers. Myself, Stacy Verono, I'm a senior pre-sales cloud engineer at SADA. I'll be joined by Amit Belgana, like a cloud infrastructure developer in the professional services arm of Google Cloud Canada. And I'm super happy to have him here. And I'll let him introduce himself when his demo section starts. But super happy to have another Googler joining the fun. So TLDR about asking questions, super simple. Everybody, if you're on the right side on the Bevy interface, you can actually see chat attendees, stuff like that. So in the chat, you'll have general, you'll have QA and DMs. So just to keep things simple so that people can actually see if you're in the Q&A and ask a question there, we can actually look and answer, which just makes things easier. So if you want to use that, that would be cool. So not a problem at all. We're like 22, so if there's a lot of questions, at least we can reply in there. So usually we do like cool stuff that happen, like blog posts and all that. So since we want to focus on demos and keep our time short, just for those of you who are, well, there's a big website where all the blog posts from Google Cloud happens, and that's the website here with the QR code. So feel free if you want to just follow the latest news, just go there, and we'll get back to a regular schedule of having cool blog posts with our Q3 event. So a little Terraform on GCP. So like the TLDR of what we can do when it comes to Terraform and GCP itself. So this is like a quick slide before we actually get into the meat of things, which is actually showing stuff, which is what everybody wants to see. Um, so when it comes to Terraform and Google Cloud, so we know, well, we all know Terraform is coming from HashiCorp. So you can have like the regular, like you have the regular flavor, the free version, which is what a lot of us are actually using. There's Terraform Enterprise, which is like a paid version with enhanced features. There's a Terraform Cloud version, which is a full SaaS offering of Terraform with enhanced capabilities in regards to state file, to also like cost control and policies, also with kind of a like Sentinel baked into this. So that's a great feature. And lately, also, I think AshiConf was last week in Europe, and also announced the configuration drift check within Terraform Cloud. Basically, like, well, once we've deployed things with Terraform, we have our state file, but if stuff start to go against what the state file is, actually that feature now brings that in, so you're notified that something's going on. Something may be created, like somebody created something manually. So nice little cool feature. So again, there's multiple things we can go like locally. I've mentioned the binary that we all download multiple times, stuff like that. Terraform Enterprise and Cloud also have a way of running things remotely. But when it comes to GCP itself, there's multiple things. Like we can actually do Terraform in Cloud Shell. So if you open Cloud Shell directly and just type Terraform, it's there. So you don't have to worry about it. You don't have to worry about versioning or making sure, like, it's just right there, the same way the Cloud SDK is. Like, you don't have to worry about downloading it. Everything is already there waiting for you. So it's a great way to actually just start doing things without having to worry too much about like which version or what. There's also True Cloud Build. So with Cloud Build, we actually have the Cloud Build, well, builders. So when you have a job running, you can actually instantiate, like Terraform itself. Basically, like in your job, let's say your CI or CD, uh, well, you'll call Terraform and run like the piece of code that's maybe in your GitHub. That GitHub is connected with Cloud Build. So you can have like a full, anytime I do a plan, so when there's a pull request in GitHub, it triggers a Terraform plan. I can see if it validates policies or not. So to tie in with our my second demo, and just say, well, the plan will fail or pass. And then you can go with Terraform Apply also, where now with Cloud Build, you also have the possibility of putting human approvers, meaning that somebody actually have to go into Cloud Build to approve the run based on the plan output that was done previously. So cool little things where Terraform actually lives within GCP without being real there. There's ways of connecting through it, like, well, we all know, like I said, like locally, remotely, or within GCP. So I wanted just to give you like a kind of a, like, this is what we can do and where Terraform can actually lives when it comes to GCP before actually going in the like the cool stuff and doing a demo. So I said it was demo heavy, so wanted to start quick and have the time to cover everything. So the first demo is around reverse Terraform. So like I said, initially there was something called Terraformer. Still is. I think it's the second time I say that, so it still is. So the Oasis RE team created something where, hey, well, if we created something through the interface, is there actually a way for us to generate the HCL code that goes against it? And maybe also like get a state file. So that would be cool. And also a great way of putting Terraform in your resume without actually knowing Terraform. So um, so that's a great idea. So sometimes people say, oh, well, like how do I create that load balancer? Like I'm not 100% sure. I can use a module, but like if I actually want to do things myself and kind of go through the motion, you can watch a video, you can do things, but it's like, what actually does it look like if I just click ops, do my thing, and then just like get that output? um, so that's actually what we're going to do with this demo. So right now in my environment, and yes, I'll go in command line. It's not like a demo through slide. I'm not going to do that. Just to give you context. So yes, right now in this environment, that I have right now is I have a project called Bulk Export Demos that has like 2 VPCs. I have my default one, which has a compute instance there with a label, and then also have a VPC called Demo VPC1 in North America Northeast, so in Montreal. Um, and in Montreal and Toronto, sorry, like the VPC is just Northeast, and then I have North America Northeast 1 as a VPC, and VPC also North America Northeast 2, which is Toronto. So also in this project, I have a cloud storage bucket fronted with a load balancer that's exposing something on the internet. It may or may not still answer. We'll see about that. And on the Toronto VPC side, I have another instance just running as like two tags, like one tag, so like two tags, IAP and HTTP server. It's fronted by identity aware proxy, so I can go in if I wanted to. So which means that I don't have a public IP, which means that also that I need a cloud router and cloud NAT so that VM can actually go outside and say, well, install the Apache package. That's my setup. So the idea is that, well, I created this, and the idea is to, well, what would it look like in terms of commands and everything? So basically, so well, okay, so the command itself is called like G Cloud resource config. It's a bulk export. So you can do that at the org level. You can do that at a folder or project level. So meaning that somebody already created something, or you just want to test like one resource in a project, you can actually do that there. We'll actually run those commands and see the outputs, but I just wanted to put that in the slides. I know it's like probably maybe it's super small, or but the idea is that I'm gonna I'll paste the information also in the chat, and also I have 2 links to recordings that I've made of this demo in case the demo gods curse me, and then nothing works. So I'll be able to also point you to those Loom recording that I made, and through the Loom recording, the description actually gives you the steps, so it's easier than just cut and paste from the chat here. So high level is basically is like we're using Cloud Asset Inventory to get things out. And then from there, we have our inventory, and then we're actually just we have like all those HCL files. And the next step, so well, that's nice. I have the HCL files, but I would love also to be able to actually run this. Is there a way to get a state file and actually be able to maintain my infrastructure, which is what we do in the next steps. And after that, like you actually have, a full terraformed stack, based on what you actually did. So so we'll go from slides to console. So here's my environment. Just to make sure, I'm just going to refresh, make sure everything's okay. So that's my bulk export demo. My buckets are there, my things are in there. Like there's nothing special here. Like my VMs instance are here. Like mentioned in the document, everything is set up here. Google's telling me I can save $6 a month. Thank you. Network services. My load balancer that I mentioned is right here. So there's nothing fancy here. I have my load balancer here. If I go there, it's actually just stop talking, Stacy, show me a demo, which is exactly what we're doing. So I'm following my own advices. So yeah, so that's my environment. It's all set up. So what I want to do actually right now is that, okay, well, all is there. What about that? Terraforming all of this. So if I go in Cloud Shell, of course it timed out on me. It's gonna go IDE. Come on, you can do it. So if I just go in IDE, Cloud Shell, blah, blah, blah. So basically that's your IDE in Cloud Shell. If nobody knows about that URL, please have a look. It's pretty cool. So what I want to do, of course, I want to make sure that like this is set up properly. And I said it's like bulk export demo. I'm going to authorize myself. So perfect. Let me actually make it just a bit bigger. And then sorry, I'm just going to move my slide over here so I can just actually follow my own documentation and go through things. So if we look at what we had before in terms of steps, um, my first command was to actually do like a resource config bulk export. You put the path. If the path doesn't exist, it's going to ask you to create it. Then you put your project to be sure, and then the resource format. In our case, yeah, we want this in Terraform. The config connector is something that I don't have installed right now because it actually I'm in Cloud Shell, so I'll need to reinstall it. I can ask him, yes, I'm in Cloud Shell. It's not happy. That's kind of normal. I just need to actually just do the sudo apt install. Sorry, I just made this here. So that way it's happy. I'm just gonna let it run. Just give me 2 seconds. That's something I can't really install in advance. Good thing is that it's not super long. I'm gonna be mindful of the time. So going back to my command, say, yep, well, please export, so you want to create your folder. So yeah, so right now it's actually just running and exporting all the resources that are tied to my project in the my infra folder. So what we'll do once this is done, I'll go up top here and open the folder. Just want to make sure that I don't disturb it. I don't want to angry the demo gods and not having a non-working demo, which would actually be super bad. So I'm just gonna let it run. Just work with me on this one. Of course, when I run it, it works fast. So one thing to be mindful of, as I was working on that demo, one day was working, the other day was not working anymore. There is actual bug in the exporting. The only way to go about it is there's a few steps, actually, that's a few extra steps that are in the Loom video that I'm going to share. Which is a workaround. Basically, we're missing a service account with an association to get this working. So, of course, it's taking forever. If not, it wouldn't be fun. So just gotta let it run. It's a demo, so if I stop it, it's not really useful. I'll just go faster in the other piece, and I'll put you while we're waiting for this. So let's open the folder. So I want to go with my infra. It's going to reload. The other itself will go in full IDE mode. So in my infra, so I have all my stuff in here, meaning that my compute address, my compute firewall. We can see like the allow IP. So like for anybody who's been working with Terraform, like this looks like something that I know. So everything that's been like my firewall rules are set up in here. Like those that are like in the project itself. Like at my instances, the information is in here also. I have my 2 instances that are set up here, one in US, one in Canada. Anything that's at the org level, also for that project, is linked to the IDs of that org. And then there's compute address. For anything that I have, like my load balancer is here, an instance that has an IP also. So everything is in here. So I'm just gonna start a new terminal. Can I recall the G Cloud config set? Thank you. All right, so this is great. I mean, like I have the code in HCL and I have my things. So what would be great is actually like to generate the import script. So there is another command which is I'm pasting here. It says the resource config Terraform generate import. You give it the folder itself. Actually, now I'm in my infra. I just need to go one level up and ask him like, can you just please read this and generate the import.sh. So if you ever work with Terraform, sorry, this is like super ugly. If you ever work with Terraform in the past, this is familiar. Like I'm actually importing the resources and location of everything inside the state file. Like that's actually, the file itself that I need to import all of this. It also created the modules.tf. So if I actually go back, if I'm gonna close this because I don't really care. I'm gonna make this bigger so we can all see. So here I have nothing. If I go in my infra, I can see the import.sh file. I have a modules.tf, which is basically just, if I just get it, it's just all the modules that are actually defined, which is all those folders that I already have. So this is my entire infrastructure stripped down in modules, and it's there. So all the HCL is there. We know, we've saw it. And now it's like, well, okay, well, now it would be actually great to get this going. So if I'm able to import things, technically, I should be able to get this to work. Uh, there's an alpha command that exists also. We only have like a modules.tf, and if we actually, open it up, the only thing that it has is like the provider for Google, of course, and the project setup, which is great. Most people say, yeah, where's my main.tf? Well, technically, we don't need it. We just need a TF. But okay, let's say if we actually want a main.tf, there's a gcloud alpha command that's here that's going to actually generate our main.tf. That main.tf contains everything that we need. So project and regions are blank, no problem. But now it's like, well, if I have two provider, it's going to complain. So what we can do is just remove it from the module. That's just me doing this. You don't really have to do it. The other thing to be mindful of, like we're doing Terraform, right? Some commands there might actually be tied up to a beta provider. So what do we do in those cases? Well, usually, we actually, we have a nice provider called Google Beta. So we need to define it also. It's not because it's coming straight from Google itself and the HCL is there that it knows it's a beta provider or not. Like for him, it's like those are resources. If they're tied to the beta provider, that's for you, the user, to actually do that. So main.tf done. Said okay. So this is kind of good. So let's actually see what's going on. So let's make this a bit bigger. Trying to be mindful of time and don't want to eat it up and have a nothing. So if I have a main.tf and I have everything, so usually we do a Terraform init. It actually, initializes all the modules that I have, get the Google beta and the Google non-beta provider, which is what's expected. And then actually, if we do a Terraform plan, we may actually have surprises, which is sometimes kind of expected. There's two things that I know, and those are intentional. This one here, our friend here, actually, if we open it up, so we know it's an org level thing. So is this guy, not this guy, is this guy here, the required.tf. I've mentioned that before, but if this is actually a beta command, I need to put it for the resource also. So this is Terraform, right? So if I do a plan again, I may just have, like I have one argument that this guy is not happy about. And I actually, for this one, and I know this is something new that just kind of popped up, I just actually need to, to comment it out completely. So we know it's a project. It's a storage bucket thing. And it's a bulk export YUL at line 6. So that one, public access. Yeah, that's another one that I need. Sorry. It's another one where I need to say provider equals Google beta, and run it again. All right, there's the long sync. That's the one that we're supposed to not work. Project logging in sync. So I'm in project. I'll have this here. I'm trying to be mindful of the time because my friend Ahmed is going to be not happy. So if I'll go back to this project link, the A required, that's the one here. This one, it's not happy with it. So what I'm going to do, because I want this to work quickly, is just remove it. So I have a plan now that actually works properly. So if I go here, comment. So I have a plan that's all green and working. So which is kind of the goal, right? So so from here, if I do my Terraform plan, I just want to make sure. I'm just gonna redo an init just to make sure my backend are okay. I'm kind of a bit paranoid on that one. I'll run my import.sh because now I have a plan that's green and just like run it. Uh, First one is because I didn't comment the line for the import of the resource that was not working. Don't have to worry about that. Now it's going through the entire process of importing everything that I had in my infrastructure. So technically, to end up giving me, um, a Terraform state file. So it's supposed to. So let's see if we're able to make that work. So I'm just gonna clean up things here on the side. Kind of spoiling the surprise that yes, I have a state file and it's living. So basically, right now it's just running. It's importing. It's creating everything it needs to do to have a state file. So we're just coming from an output from GCP, a few tweaks, and then importing things. One thing is while this is running, one thing is super important. Keep in mind, like this is not like a magic wand that just like fixes everything in terms of like creating Terraform. It gets you something from what existing, getting the HCL, keeping in mind that uh, I have an instance with a public IP. If that instance with a public IP, if I delete it and I recreate it with the same code, keep that in mind that that IP is not it's not a static one. It's an IP that's been given to me when I created the thing. So those values are hard coded inside the HCL code. So if you want to actually just reverse engineer everything and actually go with variables and Terraform the TFR and all that to be clean, you'll have to do that because if you try to recreate the same resource with a public IP that's not reserved, of course, Google's going to tell you, it's like, what are you doing? Like, I don't know this IP. Of course, I'm waiting to get actually like a new IP assigned to me, but my Terraform is forcing that value. So just keep that in mind. So it's actually doing everything it's supposed to do. And hopefully it's going to be done soon. So that way we can move along. So I can see has to drop soon. Yes, actually, we're recording the entire thing. So it's going to be available on our YouTube channel. So if you go back to the Bevy page, you'll see the recording baked in there. It's basically like our YouTube page. And from the YouTube comments also, I'll put the links to the other videos where the steps for fixing the bug is actually listed. So everything is as ran like the way it's supposed to. I have a state file. I have my Terraform lock for my HCL. So basically, I'm just doing things the way I would actually now do Terraform. So if there's anything that I wanted, like a storage bucket, so that's my storage bucket here that I have. It's super simple. So okay, well let's say hey, I want another storage bucket. I'm gonna put it right here. And instead of Yule, let's call it YYZ for our Toronto friends. YYZ, Notable Garden Northeast 2. So YYZ2, YYZ, bulk demo export is a project. And I don't want it to be a website. I don't really care. So if I just like keep this like that, just save it. And I go back to our friend here, the same way the ID is like freaking me out. And I do a Terraform plan. It's gonna get me like there's a few items that are like is it like delete after deletion? There's something you're gonna see more than just that plan. You'll see a bunch of disable and destroy, which is a value that needs to change, and the storage API also that wasn't part of the import, which is like a minor thing. But still say, hey, well, actually, like, oh, you want a bucket here? So okay, no problem. So okay, well, if actually just go and do an apply on that one, and just let it run. We'll see how it goes. If I go back to my environment here, if I go in storage browser, we'll just see if it's Still have to answer yes to a Terraform. So now, okay, so everything is run. If I do a plan, I should have like nothing to do. So it's doing everything, looking at my state, looking at what we have. Um, it shouldn't actually tell me like, yep, no changes. If I go back here and just go back to my environment, my bucket has been created. So there's nothing magical. Like this is Terraform. So if, that's the expected outcome. So it's like I took everything that I had, um, uh, get the HCL, imported it back to create a state file, adapted a few things to make sure everything's okay, and then I'm able to create resources and go as it as everything would be like normal. I've mentioned the things about like static values being set in the HCL. That's one thing. The other thing, be mindful of like all of this is one state file. So, and that's just one project, which is fine. But like if somebody would to do it at the org level, you would get like a massive state file with everything in it. So again, be mindful of maybe like cut it out in pieces that you need and put a backend.tf on the section that you need. So you have like smaller state file, easier runtime. But that's basically the way things are working with, with our friends here. It's pretty, it's pretty straightforward. I find it pretty useful, especially for customers on our side, be doing consulting, start trying to get into Terraform. Sometimes like reverse engineering is a great way to go about things. So that's the first demo. So I know that it's a lot in there. It's like drinking for a fire hose, but I'll put the step. It's honestly in the end I did like 4 commands. Like it's just like you just have to be mindful of what Google is giving you, what you need to tweak, and how you can push it back. Of course, we want this to be in source control, not the state file, but I mean like the code itself and all that. But that's best practices around like Terraform. The idea was to show you what the resource config bulk export is actually capable of doing, and actually giving you the entire infrastructure that you have in front of your face in the in the UI. So that's for that demo. I'll just go back to slides 2 seconds. So just I follow, and I want to make sure that again I'm the other one's going to be quicker. So just so that you know, I just have to. Where did I put my stuff? Okay, right, slideshow. So I hope the first demo was interesting. I love doing that thing anyway. So um, second one is around like policies. So again, well, you can enforce policies in the process of your Terraform flow, meaning that like way back when Forseti was still active and there was like other pieces around it. There was the Terraform config validator, which is still a thing that uses like open policy agent standard like Rego and all that, which is still basically what we're doing with this. That before we had the Terraform validator, validor. Oh wow, that's a nice typo, Stacy. So that's a new one. Which is missing 2 letters, which wow, yeah, probably was tired. But now that command is now like called like G Cloud beta, like it's a beta command, like Terraform vet. So it's a client-side thing that reads library like policies that are written in Rego and that you can actually apply against like Cloud Asset Inventory or CAI, and also like just like Terraform runs. So based on your assets, you're able to do things, and you centralize your policy libraries. In the past, we've talked about security. We've talked about security and pipelines. We've talked about like shifting security left, which is a nice buzzword that a lot of people are, saying. But what does it actually mean? Well, it would actually mean that, hey, maybe my security team can write policies that are run against my code, so that way, like everybody's happy, and like security is not a blocker anymore. Because most of the time it can be. Well, because we involve them at the end. If you involve them at the beginning, you don't have a problem. Um, so that's why that's how like this actually G-Cloud Terraform Vet can actually help you achieve this. So uh, of course you can say, well, our policies can actually prevent me from, I don't know, like spinning a VM in this region. Yeah, it will do so, but when you do your Terraform plan, it won't tell you. So when you do your Terraform applied, it will crash on your face with an error just because you didn't know you couldn't. So it's nice to have org policies, but it's also nice to like double down by writing said policies in a central repo that you can leverage and work with other teams in order to get things um, going. So it's not a replacement, like it's you use it on top of. So you can write your own constraint. Like I said, like this is based on the open policy agent. So just put again, like all those links and everything will be shared. So like the way you want to do Terraform constraint straight from Google, what is actually like CAI, so Cloud Asset Inventory constraints, which is a bit different than the Terraform things. And then like it's like the Rego 101, the things that, well, like it becomes, it is a standard. So if you want to know how to actually write this and how to leverage it when it comes to Terraform, I've put some Rego 101 in there. So back to demo. I'll try to keep it simple. Same thing as before. I have my slide with my commands because I'm lazy. I want to do cut and paste. So it's going to be super simple. Policy is just to give you an idea of what it's doing. And then after that, Ahmed will have the floor and won't have to worry about me talking nonstop. So first thing I need to do is actually I'll create a little policy folder. I created my info before. I'll create my policies. So that way I can work with that. So this guy's here. So okay, so now I'll go in my policies. Can I just hide this guy? No, I don't want to do Maven, so I'm just gonna go like this. All right. So I'm in my policy, so I have nothing there. There is a repo that I need to get. Actually, it's the sample repo coming straight from Google when it comes to policies. So I have a policy library repo right there. One thing, and I'm just going to go through the constraints. So I'm just keeping things simple here. That's why I have like everything like kind of pre-baked. And we'll actually go and look at one of those policies directly, so it gives you an idea of what it is. Let's nano. So this is one of my policies that I have right now. So it's for a bucket location. Again, yep, this is something that can actually be done through an org policy or anything else. You can say, hey, I just want like stuff in this region for this project, whatever, no problem. Again, all true. If you want to, you protect yourself from on the UI side of things, so anything that goes API directly, not Terraform directly, you can do that there. But everything that's in a pipeline that's running, you also make sure that those policies are matching. So just make sure you're writing those in there. So this is a pre-baked template, and the Rego that goes with it is in the template folder. Right now, this thing is allowing only one location, and it's Asia Southeast 1. So if I were to create a bucket and just put it against like Asia Southeast 1, well, technically it would fail. So, and I can list locations. So it's just a simple, I wanted to keep it simple, just give you an idea what's the way it works. So I'll keep it to Asia Southeast 1. So I'll go back to I'll go back to my infra where I did the bucket thing before here. My friend here. So I have two buckets. Actually, whoa, just me, just like everything froze for 2 seconds. I'll just kill my camera for 2 seconds. It feels like um, I'm lagging. So I'll just, maybe it's Ahmed who's trying to stop me from talking.
I'm sending vibes.
Thanks. Yeah, so I'll call it YYZ2 as a bucket. So super simple. I'll just save it there. So that way I have something actually to work with. So if I go back and I just go back here, actually, like I don't need that one anymore. It's gonna go full. All right. So if I'm following my demo, so if I go back actually to my infra, one up, I'll just need to actually just run a Terraform plan, but I want it as an output. So um, so now we know that said, okay, well, I need to create this bucket, which is exactly what we're trying to do. So of course, like nothing's working yet. So what I need to do actually, I need to feed JSON to our friend. because it's a JSON monster. So I also need to install the Terraform tools. Since I'm in Cloud Shell, same thing as before. I could have done like the G Cloud command, like the G Cloud component install Terraform dash tools, which won't work because I'm in Cloud Shell again. So I'm doing the let's do apt-get and install this thing to get it working. Now it's installed, it won't complain. So what I need to do now, I can test my constraint. So right now we know that um, we're and that's why I said the demo is going to be super simple. So this is just me running this. It takes a while, so I'm gonna just keep it running. Um, so Terraform Vet is taking the JSON output that I got before and running it against my policy library, in which I have one policy saying a bucket can only be in Asia. And it's getting this say, hey, well, when I'm feeding you as policies are I'm feeding you JSON. So that's basically what it's doing. I'm running this in Cloud Shell, so be mindful the validating resource taking forever. It's kind of normal because actually, well, I don't have like a bunch of cores and everything. I'm running in a container. I just needed to run to be happy. So while this is running, I'm just gonna go back to my slides quickly so I can wrap things up on time. Um, so like the ultimate goal, of course, is like you want to put this in a pipeline, right? You want to put this in Cloud Build, GitHub Action, GitLab CI, whatever you're using, making sure that in your flow, like when your plan is running, you have that output that you're able to get in JSON and feed it to a second step, which is your policy validator. And then your policy validator will run, and then either you fail, your go or no go. If you're a go, then after that you can do your Terraform apply. That's as simple as that. So which is the same thing as the config validator was doing before, but now actually the Terraform validator. So actually like the G Cloud Terraform vet command can actually do it properly for you inside there. So you don't have an external tool. You're actually staying with the G Cloud SDK, which is pretty nice. So I'll send the demo links. And if I'm not mistaken, after that it's Ahmed's time. But I'm just gonna go back here just to be mindful of time. Like this is the output coming from a validation. So it's validating against the policy. So we saw the constraint that was there before, and the allow list was only for Asia Southeast. And so now I have a severity I become I'm asking to actually go into Northeast too because my bucket actually is in that region and fails the policy. Um, so that's the best way to actually like control everything through Terraform and policies also. And yeah, that's basically my second demo, and I'm done. And yeah, I talk a lot, so I'll I'll shut up for the rest of the And Ahmed, the floor is yours. Thanks everyone for listening to those demos. Ahmed, glad to have you on board.
Thank you, Stacy, and thanks for everyone for attending the call. I see some uh, familiar faces and some intimidating faces that I in a while. So thanks everyone for attending. Um, my talk is pretty much about one experience I had toward last year. I was working with a customer who had two DevOps engineer, and those two DevOps engineers they decided to be as cloud agnostic as possible, and they are supporting three clouds to run their workloads. And I realized that they didn't build an infrastructure that was secure and safe, and they had a lot of risk of being attacked. Um, and when I moved like from that position to a new position, I work with a customer to implement an architecture that would make sure that their workload is not doesn't have internet exposure, and that's why I call my talk keep it private. So we'll be talking about how we can deploy a workload to be private. Uh, we have, if you can move to the second slide, Stacy, please. So specifically this scenario, like we have something that runs within a VPC, a private cluster, and I'm putting just the node pools as private. I still have access to GKE to run kubectl commands against the master nodes. Um, and we have like a PostgreSQL and Redis that are like two things that are running in private. And after that, we can create cloud storage. So we'll be building kind of this architecture. The idea here also is to use workload identity for all the node pools, like all the workload that run in that node pool, and also how the process is done to make sure that like workload that runs in specific container has access to PostgreSQL to eliminate the need of managing secrets. They will just use the service account. We can use that service account to authenticate to PostgreSQL and have access. And we'll look at like that implementation, how it's done, and all, and with the brief demo. Um, so first thing first, uh, can I share my screen? I think I can.
Yeah, just stop sharing. So you should have the share screen option now available.
Great. Thank you so much. So first things first, when I was working on the demo for today, I decided to use Terraform Cloud. And I use Terraform Cloud because I think it's a very good practice to have to like not have the state file locally, to have it somewhere. We can use straight GCS and build a pipeline for cloud build. But if we're using just specifically infrastructure build, that that there is like a free trial. That's what I've done. I started using it yesterday. I don't know what the free trial entails and what it provides, but I've been able to create that infrastructure, and I like we can ask what's when it ends and what's the limitations for it. So you can see here I have different workspaces. If we take like the PostgreSQL one, or let's take the foundation one. It's the one that I like just built my networking projects within, um, and we look at its configuration. So it's this is just the name. Like this is the version of Terraform that it's going to run, and you can specify directories for each run. So if I go back to my if I go back to my repo. This is a mono repo that has different architecture, that has different folders, and each folder is supposed to serve um, one specific need. So for my foundation, this is where I manage all my networking. I manage my folders. I create my projects. So this is can be I manage my IAM. It can be split up into like different subfolders. Teams can we have a networking team that might manage the networking, and we have like teams that would create projects. So anyways, the idea here is just to separate something that would probably not change that often to from something that would change frequently, like a GKE cluster if we're creating more GKE clusters in a specific project. um, so the idea here when we implement infrastructure, I always adopt something that we use for software development, which is like highly cohesive, loosely coupled, like software methodology. That's what I do also for infrastructure. So I strive to write to put together what is highly cohesive that needs to if I change something it might impact something else, but I still have like these loosely coupled modules that can operate separately. So if I go like see my GKE, I have remote state file, and I'm just going to my organization and workspace, and I'm reading some of the outputs that are from that TFC POC foundation, for example. Great. So this is like separated. Again, if you create a new workspace, you will specify the folder that it needs to run when the folder changes, and that's pretty much it. Um, the structure of this code, and this is public. I'll share the link in the presentation that you will receive. So I have foundation, PostgreSQL, GKE, Redis. This is just a test folder. We'll look at what that does. And I have Cloud Build. Like for now, Cloud Build doesn't um, like it only creates the worker pool. So we have a private worker pool that don't have external IPs, and that private worker pool will um, is what we will use to run our pipelines. Cool. So one thing to mention here is when we create our foundation, if we go to networking, so there is a specific way that you need to lay out your networking for to pair like PostgreSQL or Redis to the to the service itself. Whenever you create a service in managed service in GCP, it is kind of created in a managed VPC, and you can pair that VPC with your own VPC. And like we do this through service network, like through service network connections. So what I'm doing here is this is pairing my VPC, and it's using service networking Google API. This is my network, and I'm specifically pairing that network with those two CIDR blocks. And those are specific, like just like global addresses. They're just CIDR blocks. I'm providing the address and I'm providing the prefix lines. So the address and the prefix lines, like in the documentation, they describe exactly how many instances that you can have, providing providing a prefix length. The purpose needs to be VPC peering, and that's pretty much it. Like the rest is, and the address type needs to be internal. So the way we use this is in here. Let's look at like Postgres main file. So the way we use this is in the IP configuration. Like this is just using this module. This is just an example. I am like providing the allocated IP range and like the private network. So that provided IP range, the Postgres IP range is what I defined when on the networking side. So look at the example. Just read like it's pretty self-explanatory. Like it's not a really big deal. So if we look at Redis, for example, again, we're authorized network. So this is the reserved IP range for my Redis cluster. So and that's pretty much it. Cool. Is there any question, Stacy? I'll let you monitor that. Or
We're good so
yeah.
far.
Okay, great, perfect. So then let's look at how it is in here. So not bore you with like running specific Terraform commands. We know that Terraform Enterprise, Terraform Cloud did that for us. So if we look at our, let's start with our PostgreSQL. So there is a private IP, and that's pretty much it. Like it doesn't have a public IP, and it's the same for it's the same also for my Redis cluster. So let's switch gears to like this is the infrastructure part. Let's switch gears to how after that we need to to make sure that something that is running on a GKE cluster uses workload identity to authenticate to PostgreSQL. In the test, under the test, you'll see that there is like scripts, and I purposely didn't want to put it in Terraform because we can read exactly what is happening. Here, I'm just exporting the service project ID, the cluster name, and PostgreSQL instance. We'll see where it's used after. So the first thing we need to do is to create the service account. So I'm calling it just GKE SQL Connect. After that, we need to provide that service account specific things. So I think the admin has those has like already the everything that is in here. So this is probably not needed. I just need to confirm that. Um, I put it because I started first with client and after that editor and realized that I need admin. So this is something that I probably need to um, I probably need to make sure that it needs really admin and what's it specifically in admin. I was expecting it to work just with clients because we don't need anything else. We need just to connect uh, to the SQL to SQL. So the second thing is we are um, providing workload identity user to the 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 service account. This is what is used for workload identity. It always looks like this. Like it's the service account .svc.id. And this is the service account that we're binding that policy to. This is just an example how we read logs. It's just like for me when I troubleshoot, I put it in there just to read the logs. So the second thing we need to do is to create the SQL, the Cloud SQL Connect user. So you can see here that there is a huge difference between this guy and this guy. Even though we are talking here about the service account, when we create the user, it doesn't it needs to end with .im, and this gs service account.com needs to be removed. Um, so it's very important that you do remove this part because otherwise it's not going to work. So SQL user create the service account that I created minus gserviceaccount.com. This is the instance. We are creating a type of IAM service account, and this is just the project. So I'm getting the like here, just get the credentials for um, for my GKE cluster, and after that, just deploying a service account. So that service account, this is what we call a Kubernetes service account, and this is the other service account is like the GCP service account. So those service account after that will get annotated. So I will annotate the service account to like from what I have internally to the IAM service account that I have externally. So, and it needs to be like this, like IAM gke.io slash and GCP service account equal, like, and this is the value. And here it needs to have like gserviceaccount.com, which is a little bit confusing. So just make sure that you don't make that error. It's an error that um, made me lose, I think, a couple of hours. If we look at just the service account YAML file, you see nothing fancy. It's just the service account and a name, and we'll see where it's used afterwards. Yeah, cool. So now we are deploying a workload. So that workload is nothing fancy again. It's just an Alpine, um, and and that's it. Like I'm just making it sleep. It has nothing else. But that service account has a sidecar, and that sidecar is our cloud, like a GCE proxy. Um, uh, it's proxy. So and that Cloud SQL proxy needs to have a configuration. So the proxy will use the service account, the GKE service account token, would use it to authenticate to Cloud SQL for us. And when we connect, we just connect through that proxy. The command, like we need to run proxy. The IP address type needs to be private because we don't have a public IP for our Postgres. We said keep it private. And we need to add enable IAM login. So if we don't add enable IAM login, it will not probably work. So the instances, again, you need to just make sure that the instance URL, this is what you get as an output for your instance. Like usually if you go to Terraform and PostgreSQL in the States, you will see that the like one of the outputs is the instance name. So this is exactly what we need in there. And that's it. So the rest comes like you can copy everything from our documentation. I believe that the only missing part is this one. That's what I needed to add to make it work. I think the documentation is not complete, or at least when I took this from the documentation, it wasn't in there. Cool. So running that deployment. Sorry. Running that deployment. Sorry. And after that, what I did, I just like execute it, get into the container, um, added PostgreSQL client. Uh, and in the meantime, we do have a default user, which is called uh, I think Postgres. Yeah, Postgres. So you need just to put a new password for it. I like there is a process to get it like created by GCP and get and you get it. I didn't recall what the command is. I just said it myself. And after that, logged in into Postgres using the user. So because I'm using the user, then I needed to put my password, created a DB, granted a DB to, again, that user. So remember, this user is the user and it's the only first part of our IAM. And after that, we are just going to connect using this user. So let's get into here. Sorry, let's get into here. I'll just exit this. I am connected, and I will copy this. Sorry, paste. PostgreSQL host is 127.0.0.1. Like this is locally. It's going to use the default port. SSL mode disabled. Like from my container to the proxy, I'm disabling SSL. But from the proxy to the Cloud SQL itself, it's gonna use SSL. I'm going to connect to my DB. Here is like just an example name, and after that, the user is the IAM I'm using. So this guy needs to be the project ID. I'll just copy it from here. Oh. Okay, it's gonna fail. And let's export this. Sorry, my copy paste is.
How you doing? How you feeling? Yeah?
Okay.
Wow.
And let's connect.
You retain your sense of humor, which is nice.
Cool. So you can see like the change of prompt here. And I am connected just using IAM. So the other takeaway here, and not only keep everything private, if you have a mean to to use an identity, use it. Here we can use the identity from Kubernetes. We can use a service account identity. Just use it. It will avoid you a lot of headache around user management, password management. You will need probably a HashiCorp Vault or use Cloud Secret. Just use an identity if you have a way to do it. And yeah, and workload identity is the way to do it when it comes to GKE. That concludes my demo. I'll look at just the question. You're missing a double quote. It's waiting for the end string. Yeah, sorry. You are right. Good. Perfect. Yeah. So I'm on the DB. Thanks a lot, Krista.
All right.
Cool. Any questions?
Is there anything you want to get to?
So far, questions are no, we're good. Christian was following along properly and making sure the demo police was keeping an eye out. So thanks for that.
A few things I want you to think about.
I'll stop sharing.
So I don't think I got
All
a
right,
response
excellent.
from
Also,
you.
I'll reshare again. So while we do that, just let me know if everything's okay. I'm just gonna restart my video if I can. All right, so excellent. Well, thanks Ahmed for that. That was great. Also tying that up. Oh, I can see a Q&A pop up, of
Yeah,
course.
let's see. Yeah.
So yeah, so you would configure the service account, the service account in the app, exactly like a Spring Boot app properties. That's coming
Yeah.
from
So
Dre.
so the idea is to like when you provide your username password to Spring Boot in order to authenticate to PostgreSQL, you would only provide a username, and that username will be the service account without like the gserviceaccount.com. I'm repeating it because I literally lost a couple of hours to figure it out. Does it make sense, Andre?
Just gonna see if Andre. Yes, thank
Yeah.
you. So cool. All right. Excellent. So yeah, we always keep like a little buffer. In the end, we start early and I run the slide, and then like, well, sometimes we run over 105, so it's kind of okay. So I just want to wrap things up quickly. So there are future events coming. So if you want to submit your talk proposal, just feel free. QR code is there. We have a AI centric, maybe like Skynet, Cyberdyne division is going to come and present. So maybe he's going to take over, and we'll see what's going on. So there's Vertex AI and CCAI in the mix, coming in roughly probably at the start of September. So for Q3, if there's anything happens in the meantime, we'll let you know. So keep an eye out on our channel. Also, we have a little survey always in place. You'll probably also receive one, uh, at the end of the event, when we wrap up recording and all that. So feel free to just give us feedback. Let us know like what you would like for us to talk about. Hopefully, also we'll may be able to go back in real life. In Q3, we'll see. It's also cool to do it during lunchtime, but yeah, would be in real life. It's never the same. So it would be super awesome to see everybody. I want to thank Ahmed again. Thank you for joining us on this talk. Like I said, the recording will be available directly through the Bevy page, so you don't have to worry. And yeah, so I'll want to thank everybody for attending. Thanks for your time, and we'll see you next quarter. Thanks again, Ahmed, for your time. It was awesome.
Thanks, everyone. Bye.
Bye bye.